Okay folks, as you just saw, we're here at this wonderful overlook, overlooking the basin beneath the Sangre de Cristos here. It's a wonderful spot to have a lunch, to have a picnic. It's always cool up here, so I hope you're enjoying being here once you're here. I want to look a little closer at some of the rocks that we can see here. The most common rock type up here is this. It's granite. So if you've seen granite curbs in New England, or a lot of monuments are built out of granite. It's this rock, and you might think, hold on, Hobbes's hand is eroding this stuff, so how can you make a monument or a headstone out of this? Well, you've got to find this stuff before it's weathered. Remember, this granite right here is about 1.4 billion, with a B, 1.4 billion years old. It's been at the Earth's surface for a long time, not 1.4 billion years, but a long time nonetheless. And those weak minerals in here, in this case it would be biotite mica, have weathered. And we get this very distinctive type of weathering. It makes this very granular texture. It's actually a really nice gravel. The Germans have a word for this, it's called gruss. And even we English-speaking geologists use that term gruss for this weathered granite. A lot of granite in New Mexico, in its natural state, is like this. It doesn't always form really beautiful outcrops like we want it to. Some of the rocks up here, however, are much more resistant to weathering because they have less biotite and they have some of these big, what we would call a megacryst. That just means a big crystal of things like our old friend, the pink mineral, potassium feldspar or K-spar. There's a lot of muscovite mica in here, and big chunks of quartz. Quartz is a very stable and very strong mineral. So we see these big veins, like this one, of this pegmatite. It's more resistant to weathering, and it forms these nice things that tempt geologists to dig underneath when they're perched beneath. Okay, maybe that's not a good idea. There's one more rock type here that we've got to go right down the road. If you're parked in the pullout, you'll see it. It stands out. But let's take a little walk down there. So folks, we've just moved maybe 50 feet down the outcrop. We're still here at the nice overlook right by the Hyde Park Road, and we're not far from the ski basin. And here's another volcanic rock. This is an igneous rock, meaning just like the granite and the pegmatite that we saw just a second ago, this formed from the solidification, the cooling and solidification of magma or lava. Okay? Just like water, if you get lava or magma cold enough, it turns into a solid. If you get water cold enough, does it not turn into a solid? Yeah, it happens at 0 degrees Celsius, 32 Fahrenheit. If you get lava or magma cold enough, it turns into a solid. Rather than ice, we get rock. It doesn't happen at 0 degrees. It happens somewhere in the neighborhood of 1,000 degrees Celsius. That would be about 1,600 Fahrenheit. Here's a rock that we're going to call andesite. It's named after the Andes Mountains in South America because this rock is so common in those types of geologic settings. Luckily, we have it here in New Mexico too. We just have this very small little vein of it here. So this was just a little, what we geologists would call a dike, just a little feeder of lava that filled with lava and then solidified. It's not a major magma chamber. It's not something that's necessarily associated with some Krakatoa or St. Helens style eruption. Just a little thing like this. It's cutting through granite. It's literally cutting through the granite. Remember that weak granite like this and this? And because it's cutting through the granite, we can use the principle of cross-cutting relations to say with some certainty that this must be younger than this. The thing that is cutting through is younger than the thing that is cut through. Okay? So we'll explain that in more detail, maybe with some text. Again, andesite, igneous rock, cutting through granite, an older and more felsic igneous rock.